Go. So welcome back to another fun-filled, action-packed, non-flipped, frozen screen Algebra 2 classroom video. There we go. Alright, so we're on to Unit 9. This is all going to be all about exponential and logarithmic functions. So for the first half of Unit 9, we're going to be working with exponential functions. So today we're going to be talking about attributes of this new function we're learning about. But before we start, there's a concept that you need to understand before we can do this. So let me show you guys right here. Follow along. This is not actually officially on your notes, but you do need to know this concept. So take a look right here. I'm going to use the number 7 as an example. What is 7 to the first power? That's 7, right. What is 7 to the second power?
49.
49. Okay, but what is 7 to the 0 power?
0.
It's not 0.
7?
It's not 7 because 7 to the 1 is 7, so it can't be. It's not negative 7. Does anybody know this? Lynn, do you know this? What's 7 to the 0 power? That's right, it's 1. So anything to the 0 power is going to be 1, unless it's 0. But anything besides 0 that's raised to the 0 power is 1. Okay? And there's a proof behind this, but I will not waste your time with that at the moment, unless you want to see it later. I'll show it to you on your own. Okay, and let's go the other way then. What is 7 to the negative first power? Does anyone know what this is? It's not 7. Although it does have to do with this right here, 7 to the first. It does have to do with that. It's not negative 7. Wait, what did you say? This is actually going to be equal to 1 over 7 to the first power, which is what? Just 1 over 7, right? So seeing that, what do you think that 7 to the negative second power is equal to? Not quite. So what did you say, Aiden? 2 over 49? No, but that's very close. Right, it's going to be 1 over 7 squared, which is equal to 1 over 49. So, yeah, the negative, you just move it onto the bottom of the fraction. Or you can also see that, look, positive 1 exponent is 7, right? Negative 1 as the exponent is 1 over 7. Positive 2 was 49, right? Yeah. Negative 2 exponent was 1 over 49, okay? So that's kind of the relationship between the positive and the negative exponents, all right? So you need to know this in order to graph exponential functions. So now we can start. All right, the first thing that we're going to do, though, is identify types of data from points. So notice here we got 3 tables, and we're going to identify the patterns in these 3 tables. So on table number 1, what's the pattern on the x's? What's happening from x to x? You what? Yeah, you're adding 1 to each. Every time you just add 1. That's very important just so that we're keeping the x values consistent. But what is the pattern on the y values then? Plus 3, right. And how do you actually do that? You just subtract, right? You take 11 minus 8, that's plus 3. And so that's called the first difference. So when we take that difference right there, you see how we got it on the first try, right? First difference, that's going to tell us that this is a linear set of data. It's a linear graph. If we graph these points, it would be a line. Linear. All right, let's look at the second table then. What's going on from x value to x value on the second table? Adding 1, right? But what about the y values? Plus 3 from the first 2 points, right? But then what about the next 2? Okay, plus 5, and then? Plus 7. That's not consistent like the first example, is it? Right? We've got 3 and then 5 and then 7, right? That's not the same number. But now look at the 3 and the 5 and the 7. What happens between each of those? You're adding 2, right? So now we have that constant that we're adding. This time we went on the second time we took the difference, we were able to see the constant number, right? So this is not going to be a linear. What do you think this one would show? Remember, linear is like this, right? It's just x. What do you think this second table is going to show? Linear, we were able to find the constant on the first difference. The second one we found on the second difference. What did you say? That's right, it is quadratic. Quadratic, we found our constant on the second difference, and remember quadratic is x squared. Right? So, just adding on to this concept, what do you think it would have been if we found the constant on the third difference? If it was the third difference, what would it be? On the first difference, it was linear. Second difference is quadratic. What do you think the third one would be? The second difference is squared, so what would the third one be? Cubed. That's right, it would be cubed. It would be cubic. That's right. So that's the idea, okay? All right, anyways, but let's look at the last one. Last one's a little different. So what's going on from x to x? Plus 1. But then how do you go from one y value to the next y value? Times 2, right. Look at that. Times 2, every single time it is taking you from one y value to the next one, right? So, in this case, when you're multiplying, the pattern is multiplication. That is going to show us our new function, which is an exponential function. Exponential function. And in this case, exponential function looks a little different, but you're going to have a number in front. You don't know what it is. It's a, so just put that there. But you see how we saw that we're multiplying by 2, right? So that would tell us that we're going to have a base of 2, and then x would actually be up here as the exponent. But we'll see more on this in a second. I'm just showing you that just because that's what it is. All right, now let's take a look at the parent function, right? We always want to look at the basic type of function. Now for linear, quadratic, square root, absolute value, right? All you're doing, like all there is really is an x and then some kind of operation on x, right? However, for the exponential parent function, it's a little different because x cannot be by itself for exponential parent function. You actually need a base. You need a number, so it's going to be b. I'm just putting b here. That lets you know it's the base. B is a constant number, but it changes from problem to problem. But it's going to be a solid number, all right? Now x is going to be the exponent. Label this. X is the exponent. That's why it's called the exponential. Exponent. That's why it's called exponential function, because x is your exponent. And b is the, what did I say it was? It starts with a b. Base, yeah. Is going to be a constant, yeah, but it's called the base. Now there's a couple of rules about b though. One of the rules is that b cannot be negative, so b has to be greater than 0, okay? Otherwise you'd be flip-flopping around on your graph and that would be weird. B has to be greater than 0, and b cannot equal 1. Because if b was 1, right, it doesn't even matter what x is, it would always be 1, right? And that would be a pointless graph. So b is not equal to 1, and it has to be positive. So let's take a look at how we would graph these exponential functions. All right, so example 1. Graph f of x equals 2 raised to the x power. All right, so you can tell it's an exponential function because x is the exponent. All right, so we're just going to get some points and graph it. So we're starting off with, x is -2, -1, 0, 1, 2. They just gave that to us. And we're just going to plug those points in, plug those x's in, and see what we get. So we have 2 raised to the x, right? If I substitute in the 0 for x, I would have 2 to the 0 power. And what does that equal? 1. So one of my points is going to be 0, 1. Next up, let's see what happens when we put in 1 for x. So it's going to be 2 to the first power, which equals 2. So that's another point. 1, 2. Let's graph that one. What do you think this next value would be? 2 to the second power, which is going to be 4. That's right. So 2, 4 is my next point. Oh, that's 5. There we go, right there. So those ones are the simple ones to find the value for. But let's go in the opposite direction now. What about 2 to the negative 1 power? What's that going to be? 1 over 2. Very good. Remember, that's why we went over those concepts earlier, so that way you could find this one. So it's going to be 1 over 2. So that's another point. Negative 1, 1 over 2. And lastly, we've got up here 2 to the negative 2nd. What's that going to be? 1 over 4. That's right. So you see down here it's 4, so we go 1 over 4. Alrighty, so we got negative 2 and then 1/4. Okay, so if we connect these points, our graph is going to look something like this. Okay, notice how I drew it though. It gets really close to the x-axis, right? But it's never going to touch the x-axis. Okay, it can get